Have you ever wondered what would happen if an asteroid were to hit Earth? Let's talk about a celestial body that's been making headlines recently, the asteroid 1994 PC-1. This space traveler is no small rock. It's approximately half a mile wide, roughly the size of the Empire State Building. Now you might be thinking, that's quite large, and you would be right. But what's even more intriguing is its classification by NASA as potentially hazardous. This isn't because it's planning a surprise visit anytime soon, but due to its orbit. You see, this asteroid's path crosses Earth's orbit. This brings us to the heart-stopping question. What would happen if this asteroid decided to take a detour and hit Earth? Well, the energy it carries is more than a nuclear blast. The impact would be catastrophic, causing damage on a scale hard to comprehend. But before we get carried away with doomsday scenarios, let's remember this asteroid is expected to pass by Earth without incident. And if you're wondering when you can wave hello to 1994 PC-1, it orbits the Sun every 1.5 years. However, it won't come this close to Earth again until the year 2105. So, what if this celestial traveler decided to pay us an unexpected visit? Let's delve deeper into that in our next scene. Now that we know about this space intruder, how do we keep an eye on it? NASA has been vigilantly monitoring this cosmic voyager, known as 1994 PC-1, since its discovery in 1994. You might be wondering, how does NASA manage to keep tabs on an object that's hurtling through the vast expanse of space? Well, the primary tools of the trade are telescopes, both ground-based and those stationed in space. A telescope's job is to scan the skies and provide detailed images of celestial objects. In the case of 1994 PC-1, these telescopes help gather data about its size, shape, speed, and most importantly, its trajectory. This information is crucial in determining whether the asteroid poses any threat to our planet. However, it's not all smooth sailing. Ground-based telescopes, while effective, have their limitations. They can only survey a limited portion of the sky at any given time, and their functionality is often hindered by weather conditions and light pollution. To overcome these limitations, we need a better vantage point, and what better place than space itself? Enter the Near-Earth Object Surveyor mission. This space telescope, currently under development by NASA, is designed to spot potentially hazardous asteroids like 1994 PC-1. Stationed in space, it can avoid the limitations of its ground-based counterparts and provide a more comprehensive surveillance of near-Earth objects. It's like having a bird's-eye view of the cosmic traffic around our planet. The mission of this space telescope is not just to spot and track asteroids, but to catalog them as well. This cataloging is essential for understanding the paths these asteroids take through the solar system. By doing so, we can predict if and when they might cross paths with Earth, giving us ample time to prepare and respond. So we've got the tools to track these celestial speedsters and the technology to predict their paths. But this leads us to another crucial question. The question then is, can we stop it if it's heading our way? What if we could stop an asteroid in its tracks before it reaches Earth? Let's talk about the defense systems being studied and tested to protect our planet from these celestial intruders. It's a bit like cosmic billiards, but with the stakes a whole lot higher. One such defense system is NASA's Double Asteroid Redirection Test, or DART for short. Imagine a game of pool where you aim the cue ball to hit another ball into the pocket. In this case, the cue ball is DART, and the pool ball is an asteroid. DART is designed to change the course of an asteroid by hitting it, not to destroy it, but to nudge it off course, changing its trajectory and steering it away from Earth. It's a strategy based on precision and timing, requiring early detection and a lot of space to work with. On the other side of the spectrum, we have Professor Philip Lubin's PI Terminal Defense for Humanity. This system takes a more direct approach. Instead of gently nudging the asteroid off course, Lubin's system aims to pulverize it, smashing the asteroid into smaller pieces by firing rods filled with explosives at it. It's a bit like taking a sledgehammer to a rock. The large pieces become small ones, which then, ideally, burn up in Earth's atmosphere. Both systems have their merits. DART's method is less destructive and less likely to cause collateral damage. However, it needs more time and a lot more space. On the other hand, Lubin's approach is more immediate, designed to deal with threats that have less time to act. But it's also more destructive, and could potentially cause a rain of smaller meteorites. So, we have some solid plans in place for asteroid defense. But what if we don't have much time to act? Imagine we had only a few hours warning of an impending asteroid strike. What then? Quite a chilling thought, isn't it? But it's a scenario that some scientists are seriously considering. Enter Professor Philip Lubin from the University of California, Santa Barbara. He's studying a defense system that's designed to deal with threats that don't give us much time to act. His project, affectionately called the PI, or Pulverize It, Terminal Defense for Humanity, is a bit like the universe's own rapid response unit. This system is geared to tackle asteroids when we have a short warning period. Think 5 hours or so. That's right, just 5 hours to prevent a potentially catastrophic event. It's a stark contrast to other methods that require years or even decades of preparation. But how does it work, you might ask? Well, the PI terminal defense system focuses on smashing large asteroids into small, harmless pieces. It does this by firing rods containing explosives at the incoming threat. It's a bit like throwing a spanner in the works, but on a cosmic scale. Now, to be able to respond rapidly, this system would need to be pre-deployed. That means placing it in orbit or setting it up on a lunar base, ready to swing into action at a moment's notice. It's a bit like having a fire extinguisher handy. You hope you never need to use it, but it's good to know it's there if you do. Professor Lubin's approach is not just about clever science, it's also practical. It's cost-effective, testable, and can be deployed using existing technology. And with a logical roadmap of development and testing, it's more than just a pipe dream. So, even in the face of a short warning asteroid strike, we're not entirely defenseless. There are bright minds out there, working hard to ensure that our planet stays safe from these celestial threats. It's clear that a lot of thought and effort is going into ensuring our planet's safety from potential asteroid hits. And that, my friends, is something to be grateful for. So, what can we take away from all this? In the grand scheme of things, we've come to recognize the importance of tracking and studying near-Earth objects. Asteroids, like our recent visitor 1994 PC-1, serve as potent reminders of the vast universe that lies beyond our planet. These celestial bodies, while fascinating, can pose potential threats to our existence, underlining the urgency of monitoring their movements closely. The significance of initiatives like NASA's Near-Earth Object Surveyor mission becomes clearer in this context. By cataloging nearby asteroids and tracking their paths, we're not merely expanding our knowledge of the cosmos. We're also taking active steps towards safeguarding our home planet. The mission's aim to detect 90% of near-Earth objects larger than 140 meters is a testament to the scale of this endeavor. But tracking is just one side of the coin. The other critical aspect is the development of advanced defense systems. Efforts like Professor Philip Lubin's Pulverize It, Terminal Defense for Humanity, and NASA's Double Asteroid Redirection Test are paving the way for innovative solutions to mitigate asteroid threats. By focusing on smashing large asteroids into smaller pieces or altering their trajectory, these projects offer a glimpse into the future of planetary defense. It's also worth noting the potential catastrophic effects of an asteroid hit. The Tunguska event and the Chelyabinsk meteor serve as stark reminders of the damage these space rocks can inflict. It's a sobering thought that emphasizes the need for preparedness, even when the threat may seem distant. Our exploration of the cosmos is not merely about satisfying our curiosity. It's also about ensuring our survival. In the face of potential asteroid hits, our best defense is a combination of constant vigilance, in-depth research, and innovative technology. While the threat of an asteroid hit may seem distant and unlikely, the work being done to protect our planet is very real and very necessary.